So remember, every real number has rational approximations. What do I mean by that? No matter how far I zoom in, there will be rational numbers close to my irrational number. And at that distance, I can't actually tell them apart, at least not visually. So for example, I can say that, as long as I'm far enough away, I can't really tell the difference between the square root of 3 and 1.7. They're just too close together. Or maybe from that distance, I couldn't even tell the square root of 3 apart from 1.8. I know in my head that they are different. They do different things algebraically. But from a distance, they're pretty close together to a point where I can't tell them apart. So 2 to the power square root of 3 should be pretty close to 2 to the power 1/7 and 2 to the power 1/8. Again, assuming that this is going to be a continuous function in the way that this scatter plot is suggesting. Well, let's zoom in a little bit closer and, let's zoom into the point where I can actually tell square root of 3 is different from 1.7. Well, I got to take a bigger decimal approximation. As I zoom in, maybe I'm at a point where I can't tell the difference between the square root of 3 and 1.732. Get a little bit more decimals there. Well, at that zoom, my 2 to the power root 3 would look a whole lot like 2 to the power 1.732. And this thing is a number I could calculate, right? I would turn this finite decimal into a fraction, which I can always do. The denominator is going to be some power of 10. And take some really big power, take some really big root, and I can just calculate that. Okay, so I'll zoom in a little bit more. I'll zoom in so I can tell the square root of 3 is different from 1.732. They'll be, spreading out as I zoom in. Maybe now I can't tell the difference between the square root of 3 and 1.7320, right? So then my 2 to the power root 3 would look like 2 to the power 1.7320 and so on. Is this going to end anywhere? So I'm starting to get this idea that, okay, 2 to the power square root of 3 really should live somewhere on this number line, which means it should have these approximations. So if I'm going to define it exactly, how about I use a limit? So this slide is setting us up to be doing this process on both sides of 2 to the power root 3, so numbers which are smaller than that, numbers which are larger than that. So as I get closer and closer and closer to my computer screen, as I zoom in further and I see more and more numbers that are close to 2 to the power root 3, well, how do I actually get a handle on that? Well, I will just say 2 to the power square root of 3 is equal to the limit of 2 to the power, let's call it r for rational. I can calculate 2 to any rational power. And as r gets close to the value of square root of 3, I can make that rational number as close as I want. Well, then my 2 to the power r will get close to some limit. And that is what defines this exponential function. So I can just fill in that curve via limits.